Hello, everyone, and thanks for joining this session. While we are waiting for Vasil Momchev, who is the chair of this session, to arrive, and the people to join the session from the previous ones, I will focus your attention.
Hello.
Hey, Vaso, I was just saying that we should, if the audience has any questions, they should leave them in the chat, because at the end we have planned a short Q&A session in which Alexander will be able to cover your questions. So, Vasu, to you.
Okay, fantastic. Thank you. Our next speaker is Alexander Wahler, the CEO of Onlim. His presentation, Talk to Your Graph, reminds me for a movie, Ex Machina, where a CEO of a technology company developed a robot capable of passing the famous Turing test. A test of a machine's ability to exhibit intelligence equivalent, or why not better, than a human being. Without giving you any movie spoilers, the story took a not so expected direction. Let's hope that Alex and the Onlim team has a better way to control their super intelligent virtual conversation assistant via a knowledge graph. Welcome, Alex. The broadcast is yours.
Thanks, Vasil. So, great intro. So, we take, of course, the challenge of the Turing test and how we can do it. So, I will introduce you a little bit, maybe a different topic today. So, it's, of course, also about knowledge graph, but not how to build a knowledge graph or how to manage a knowledge graph or whatever you need to do here. But my presentation will be more, how can you access all the knowledge in natural language? And I think this is one of the major challenges that we are facing here in future, because we are used to it that we are using search engine with keyword-based searching. We have now already semantic search based on the knowledge graph, but the best way is, of course, that we can access knowledge in natural language in the same way as I'm talking to you, to run either a dialogue or to do a search, or also to use a voice assistant on it. And this is, of course, also what I want to show here, what is the path that also Onlim is taking, and using graph databases here, how we can access all this great knowledge that you build with your graph database, all the knowledge graphs in natural language in an easy and comfortable way. So what we are doing, maybe also from Onlim side, so what we have done, we built a platform for natural language enabled enterprise. And what I quickly show you here, so the components that we have in the platform, we have, of course, the knowledge graph data platform, so where we can easily integrate new data sources, build the knowledge graph, also having different models. And what we have done, actually, we started with the conversational AI part, and we connected actually both parts together, because what we have seen, without great knowledge, you cannot run a great conversation or also access this data. And then you have, of course, the different channels on the right-hand side, because when you have your knowledge, you have to know how to run conversations or access the knowledge in natural language. Then you need the different channels, and channels, everybody's aware, are chatbots, search engines, and also exactly at some point where we want to get, and they exist already some at the moment, are personal assistants, virtual personal assistants, where you use either maybe in your VR or augmented reality environment, or just have your earplug and you're asking a questions and get the relevant answer for it. And what I am showing you in the talk today, I will bring you a little bit knowledge about conversational AI, how it's working today, and also what is actually the future, how we see it, and not also how we see it, but how we are doing it already. So everybody that tried chatbots already knows maybe chatbot. So you you're having questions, and then you get a kind of answer. Sometimes the answer is okay, but sometimes it's not really okay, because you think, okay, it's not really quite precise. And this is the type of dialogue, maybe, as you see also here in the picture. So you have a conversation with somebody, and the person is not really listening, so she gives you an answer. But this is actually not the type of dialogue we want to run, because it's, of course, frustrating at some point when you just understand the intent on a high level, but you cannot run a quite detailed conversation. And therefore, what we have seen, it's we need actually to go into more details. And it's not only that we can recognize the intent of a sentence, but we need, of course, recognize what are the entities here that we have, but also what is the context here. And on the other hand, you need, of course, you need also to understand, when you want to run a dialogue, you need the proper knowledge. So these are two parts that you have. So you need to annotate, you need to get training data that you understand actually the dialogues also here. And this is exactly what you see in this dialogue. So when you have now a conversation, said, okay, hey, how you make pancakes, do you need milk or water? I want to get a precise question or answer out of it. So also, if I understand the intent of the question, that is, what are the ingredients here? I need to find actually the proper answer in it, and to process this. And how we are going to do this, and also why this is something that will scale at the end, just shows you actually the next graphic. And I think everybody is aware how a knowledge graph is set up. So what we are doing is actually we say, okay, we have the graph. So we have modeled the recipe of the pancakes. We know what are the ingredients. And when we want to run actually a dialogue out of for recipes, it's, of course, we need training data. We need to train the machine so that they also understand the proper entities here, maybe synonyms and so on. And then you can jump into it, you get the intent, and you jump into the right node and say, okay, do I need milk or water? So here you see we have connected this with milk. And we can then also, when we know, okay, milk is the right answer, and what you also have seen here in the previous slide, we can also do the follow-up question, because we see, okay, we also have, you can also have berries, raspberries or blueberries, whatever. Berries is a category. You go down and say, okay, strawberries, raspberries, it's not modeled here, but you see it's exactly how you can run a dialogue. And this is something how we connect actually the graph and the knowledge out of it. And I go a little bit more into details in another example that you see how these two things actually are set up, and how actually the dialogue is directly connected to the graph here. So what is the problem actually that we are solving here? And this is a little bit when you are doing conversational AI, it's, of course, you have unlimited number of dialogues at the end of the day. And this is what you see here on the left-hand side. When you have an unlimited number of dialogues, that means you have an unlimited number of predefined user queries with selection options that you need to maintain. So your dialogue trees and dialogues gets really complex. And therefore we said, okay, we cannot do this because it does not scale. And in our power-driven knowledge graph, so we say, okay, the knowledge that we use to run the dialogue is actually our knowledge graph itself. So we just need to recognize, of course, the intent, so which is a standard in conversational AI, how to connect this. And then when we are in, we can directly, according to the nodes and edges, run the dialogue and provide a proper answer. And this gives us a way that we can dynamically build the dialogue based on the knowledge and also on the data that is actually the instances that are in here. And we don't need to pre-configure everything. And how this will look like, I will show you now in another example. So we will run step by step through it, and I also show you then a video. So what we have built here, it's an example where for retail. So we have a product recommendation. So we have a lot of products about bikes with all the different models, colors, specifications. So bikers amongst the audience here will know. So when you're there are a lot of questions you have to answer here that you get your right bike. And it's of course, if you are looking for something or you want recommendations, you want to get straight to the point. And this is exactly how we can build a dialogue, and also how we difference from other dialogues that run the dialogue tree. And maybe at some point you're in a dead-end street because you don't have data there, you don't get an offer, which means you're frustrated. So how do we start? And you see here, and I also then show you the final product in a short video, how this looked like. So this is a knowledge-driven dialogue. So we have a product. So you see here the scheme, how the graph is built. The product has a product type. We have an audience defined, has a color, has an offer, and quite a lot of other specification here. So when we now run the dialogue for the product recommendation, we do it in the same way as you go into a shop and you talk to the shop assistant. So when you go to the shop assistant and then you say, okay, I want to get a bike, and the shop assistant knows maybe I have, in our case, 46 bikes in the shop, and maybe he has 200. He will not give you a list of 200 bikes and ask you which bike you want, but he will start a conversation with you. And this is exactly also what we are doing, because we see, okay, our product, we see how is the specification in the graph. So how is the model here that we built in? What kind of data do we have in here? And then we start, okay, we ask, okay, what kind of bike do you like? You like a city bike, you like a children bike, e-bike, whatever. So because we know this, we can also give recommendations exactly in the same way as you do it in a dialogue. This is, of course, also working with a voice assistant, independent, which channel you are using here. Then you go into more details. And what we also do, and as like, okay, I still have too many results, so I need to ask more questions actually to get the proper results out of this. So the next question is, say, okay, maybe we know now what is the product type. And we ask, okay, is it for you, or is it for me? Is it for your wife? Is it actually a children bike? So who is the target group here? And also quite important is we saved the context. So we know, okay, when you run a dialogue, you also need to be aware of the context so that you know, okay, we are talking now already about city bikes. We don't need to repeat this. So then we get the audience. So we get, okay, who is the bike for? So it's you want to get a bike maybe for your wife, so it's a female bike. We have selected here. Also here we save actually the context, and we still have too many offers. So we say, okay, before we tell 22 offers, which is still not quite appropriate for a voice assistant or a dialogue, we need to ask another question. So we go down and say, okay, maybe you have a special color that you would like to have. So we know the colors, we can narrow down the result again. And also same principle how we do it here and run again. And then actually we are at the point where you actually see, okay, we have now narrowed it down. So we have the color, chosen color, it's green, and we are here ending up at the last step. And you see, okay, we are getting actually 3 offers here, or 2 offers in this case. And then, of course, you can also build in the offers exactly the recommendations and say maybe you want to say, okay, where can I, when it's an online shop, you can say where can I buy it, so that you then give the recommendations, what are offers, where is the address of the offer, so all the information that you modeled actually in the graph, and this is really quite powerful here. That you can really model dialogues in the same way as we do it here for humans. So what I will show you now is how this is looking for in the conversation, that you see you modeled now everything, and it's really quite nice when you see everything in the conversation. So I switch quickly to my screen, so you get now a short video that we prepared. So hope you can see the screen here. And you see here where we have set up a chatbot. So this is a normal website where we integrated here. And what we are doing here, we start actually in this widget with the classical product search. And classical product search is exactly as I presented before or described. So you're running a predefined dialogue where all the questions actually are predefined, and then you have your criteria and you don't get results, so you're frustrated. Now we are actually running it in the same way like a human or a shop assistant is doing it, because you just get results presented where we also have data or where we have offers here. And this is actually, as you see here, same as you have done in the slide. So you get first the results, then you choose what you like to have. The result is narrowed down. You select, okay, who is using the bike. Then you select the color, and you get actually here quite nice results. And also, as I said, you can do offers connected actually with other items. And also here, we know the context, actually, what you have done, so quite important here. So we are typing here quite a message. So you say, okay, you have it also in blue, and you get the blue offers here when you find something, but also the context, everything we recognize. So we can really run quite nice dialogues. We also have the offers and the stores that have the offers, because everything is modeled in the knowledge graph itself here. And then we connect the dialogue. So we say, okay, I also want to know where can I do a bike tour, as you have seen here. And then actually we find bike tours when this is also included here. So really you have quite a lot of information that you can actually connect here. And when you scroll down, we also have here then the same as we do it also in the search. And here we do an example. So when you go at the moment, actually, for example, to quite famous shop like IKEA, and you want to look actually for a product, you don't find it, because you ask IKEA in a quite natural language a query that they cannot actually perform. And what we actually have done here, when you ask, for example, in our search engine, this natural language query, then you will get exactly a result, because what we're doing, we find the intents, we extract the entities here, and we can, of course, provide you then the proper results. And you see in the video, so children bike, first was the color white, then was the color green, now white. And you can also then look for another bike. So it's really working quite well. And this is, of course, something that provides you much better results here. And brings you in another world actually of conversational AI and dialogues. So I finish now my talk. So just sharing again another screen, and then we are ready, of course, for a couple of questions. So, and also to see the connection also between graphs and conversational AI. It's not nothing maybe that we are doing, but of course also we are connected to the big analysts, and also when you look at what Gartner is saying here, it's actually, they also see, of course, exactly as Vasil started his entry point, our goal is super intelligence. And at some point, of course, a couple of years ago, when the Turing test was performed, it was not successful, and we didn't. The scientists and the tech guys didn't succeed. But we are quite advanced already here, and also in our platform. Of course, we started from the very beginning to add the graph technology here, because we said we started, maybe we said, okay, of course you can go step by step and you'll get here a list of features that are necessary here, but we have seen from the very beginning classical databases are not scaling with dialogues here, so we need to have something else. And this is exactly what we have done. And our approach was and is, and this is actually very really, you have seen the results here. So we said, okay, we have two approaches in the AI. It's a symbolic AI and it's a non-symbolic AI. So in that sense, the graphic and semantic suites, we need to connect and combine with the machine learning. And what we are doing, we say, okay, our approach is we start from the knowledge graph. We use then all the data and also the structure semantics that is in the knowledge graph to do the setup and training for the natural language understanding component. This gives us the power actually to run these knowledge-driven dialogues. And of course, we also are using analytics. So we are connecting the data here. So we're doing a lot of knowledge curation to use the full power, of course, of the knowledge graph, as you have also seen in the demos. And then, of course, also the insights and analytics so that the users get more information about the dialogues also, but also we use it again to optimize the whole systems. And this is our recipe for super intelligence. And who is interested, of course, happy to tell you more. Just connect with me. We can all the time give a quite detailed demo and tell you more, of course, how our platform is working. And we are use case agnostic. So that means these use cases today have been just a couple of examples. You can use it for everything. And yeah, so looking forward now to any questions from your side. And thanks also for the opportunity today and speaking at the Knowledge Graph Forum. Thank you.
Okay, fantastic talk, Alex. It was great listening to you. So the key highlights I take is that if you have the knowledge graph, it should be pretty straightforward how to start this virtual assistant on top of it. So my guess is that probably you, while the people are taking the time to ask some questions, so I guess that your systems, I guess they get some quite unusual requests if you have these natural language questions. Probably it would be funny to see some of them. Anyway, my first question is, do you do any modeling or behavior of the client? And to give an example, if yesterday I bought a tennis racket, then the system to know the next day that I'm more likely to buy some tennis shoes, for example. Do you have this on the roadmap, or how do you see this user personalization in this trend?
Yeah, we have actually we can do this already now because how are we doing this? So it's of course CRM system are there, And in that sense, what we are doing, we connect to the CRM system. So that means, of course, when somebody is doing a transaction and you have the data of the user, either you're using already a CRM system or not, we have actually always two options. Either we import the data directly in the knowledge graph so that we say, okay, it's important data. Then we can, of course, extend the knowledge graph on a daily basis, on a hourly basis, whatever is necessary here, and get the data in the knowledge graph so that we say, okay, we know about this transaction. And then we have the node and the connection in the knowledge graph. And the other thing is also what we are doing. We have nodes in the knowledge graph where we do direct service calls. And then if you see, we can also do during runtime, make a service call to the CRM data and see, okay, what are recommendations that I can do exactly for this user. And then we can also fulfill, of course, this example. So that means when the systems are performing enough, then we can connect also the knowledge graph knowledge with knowledge from external services. So this is actually integrated already on our side, so we can do it.
Okay.
And the only thing is, of course, the system, which is then all the GDPR issues when you use personalized data. Also this, we are ready for it, but gives maybe a little bit more overhead on it. But
yes, I guess this is also a very good case of data virtualization, where your software will connect to the CRM systems of the clients and will be on demand asking this. So could you tell us something more about the scale of the products? What is really the typical implementation? What is the volume of the products and how you have tested this system?
Actually, in that sense, the volume is, of course, when the underlying cluster system, and we are using GraphDB here, when we can do the cluster system and the performance here, then we don't have any volumes problems. And actually also we have quite good experience here. So in the performance, it's of course we have quite high response times requirements, because in a dialogue is, of course, you cannot wait 10 seconds to get an answer here. So the response time is something that is quite important for us. And so far, we have good experience, and it's of course what we need to do when we get more data in the knowledge graph. We need, of course, to do classical clustering and everything that you need to get a high performance knowledge graph and graph database here. And as I said, our requirements are definitely quite high than a normal query requirements in the back, because you see the knowledge graph is directly accessed during the dialogue, and the sensibilities of users for dialogues and also voice assistants are quite high. That means if you don't get an answer immediately, they get nervous and say, okay, system is not working, and so far everything good. Yeah.
So there is a follow-up question. So give us some idea about the response time to simple and what is a complex question. How basically is this a single query, or what is the typical response time?
To be honest, I don't have now the numbers in my head, but I'm happy to connect. And but the response time on the end user interface, and this is not, of course, the response time because you have different systems included. So it's an aggregated response time. So what you have to see that we try to be below 1 to 2 seconds in total, but it's the aggregated time already. That means for the query on the graph database, it's a couple of milliseconds that you get here then available.
Okay, so there is another question which I don't fully understand about. Can we see this slide for reference? So maybe Maxim, if you have any more specific question, please type it and we can try to answer it. Okay, that was Alexander Wahler with his presentation, Talk to Your Graph. Many thanks for joining the conference, and if you really need to speak to Alex, you can find him in the lobby.
Yeah.
Thank you all. And let's
happy to connect and give more details also on the numbers and figures.
Fantastic.
Okay, thanks a lot for the invitation. Thank you.